Hi and Assalamualaikum. Here I will introduce my group member. First, my name is Nur Shafiqa binti Rosli. My metric number is 2020826706. And my friend is Aisyah Fakihah binti Muhammad Anwar. And her metric number is 2020818462. Third is Nur Farahana binti Muhammad Rafi'i. And her metric number is 2020818168. And fourth is Wan Nur Ilani binti Wan Kaswadin Hisham. And her metric number is 2020603396.
Logical connective. Logical connective is also called a sentential connective or propositional connective. It is used to combine premise statement, which is a statement that only has one subject and one predicate. These premise statements are combined using connective to form a compound statement. The true value of compound statement is completely determined by the true value of its premise statement. There are 5 logical connectives that are commonly used, include conjunction, first statement and, disjunction, first statement or, negation, first statement not, conditional first statement if then, and biconditional first statement if and only if. Logical connective is a basic unit that used to interpret English statement to logical structure of an argument. This connective is too easier for us to understand and used to find the true values of a logical statements.
Definition of truth table. In logic, a truth table is a chart of rows and columns showing the true value, either T for true or F for false, of every possible combination of the given statement, usually represented by uppercase letters such as P, Q, and R, as operated by logical connective.
Assalamualaikum, I am Aisyah, so I will continue the presentation for content. Two propositions A and B are said to be logically equivalent or simply equivalent when their truth tables are identical. There are 4 statements. Firstly is conditional statement. The symbol for conditional statement is P implies Q. Secondly is inverse statement. Its symbol is negation P implies negation Q. Thirdly is converse statement, with the symbol Q implies P. And the last statement is contrapositive, with the symbol negation Q implies negation P. Next, I proceed my presentation to explain about the detail of 4 statements. First, conditional statement. A conditional statement P implies Q. A conditional statement takes the form if P then Q. P is hypothesis and Q is conclusion. Conditional also known as implication. The second statement is inverse. An inverse statement, negation P implies negation Q. The inverse statement is the negation for both sides of the conditional statement, which are negating both the hypothesis and conclusion of the original conditional statement. The third statement is converse. The converse statement, Q implies P. We can write the converse by swapping or interchanging the roles of the hypothesis and conclusion of the original conditional statement. The hypothesis of the conditional statement, P, becomes the conclusion of the converse, and the conclusion of the conditional statement, Q, becomes the hypothesis of the converse. And the last statement is contrapositive. The contrapositive statement, negation Q implies negation P. Contrapositive statement is formed by negating for both sides of the converse statement, the negation of hypothesis of the converse statement Q and the negation of conclusion of the converse statement P. Okay, next I am going to explain about the truth tables of a conditional statement and its converse, inverse, and contrapositive. From the truth tables of a conditional statement and its converse, inverse, and contrapositive above, it shows that conditional is logically equivalent to contrapositive and inverse is logically equivalent to converse. That is because the true value for both statements are identical. Moving to example question on logical equivalence, given 2 statements which are P, you are in a classroom, and Q, you are in a building. For the conditional statement with the symbol P implies Q, The sentence is, if you are in a classroom, then you are in a building. Then, for inverse statement with the symbol negation P implies negation Q, the sentence is, if you are not in a classroom, then you are not in a building. Next, for converse statement with the symbol Q implies P, the sentence is, if you are in a building, then you are in a classroom. And the last statement, which is contrapositive with the symbol negation Q implies negation P. So the sentence is, if you are not in a building, then you are not in a classroom.
The example for logical equivalence is consider that we need to use the truth table to verify the following equivalence statement. For example, we have the statement P and Q or R, and P and Q or P and R are equivalent or not. Send the true value for P and Q or R, and P and Q or P and R are identical. Therefore, we can consider that P and Q or R are logically equivalent to P and Q or P and R.
Third question is, if triangle ABC is isosceles and contains an angle of 45 degrees, then ABC is a right triangle. First, we have to divide the statement. P is triangle ABC is isosceles. For Q, triangle contains an angle of 45 degrees, and for R is ABC is a right triangle. Then we will create the symbol. In bracket P conjunction Q conditional R. Now look at the column. First statement is conditional. The symbol is in bracket P conjunction Q conditional R, and the sentence is, if triangle ABC is isosceles and contain an angle of 45 degrees, then ABC is a right triangle. Second statement is inverse. A negation in bracket P conjunction Q conditional negation R for the symbol, and for the sentences is, if triangle ABC is not isosceles and does not contain an angle of 45 degrees, then ABC is not a right triangle. For the third statement is converse, and the symbol is R conditional in bracket P conjunction Q. For the sentences is, if ABC is a right triangle, then triangle ABC is isosceles and contains an angle of 45 degrees. For the last statement is contrapositive. The symbol is negation R conditional negation in bracket P conjunction Q. For the sentences, if ABC is not a right triangle, then triangle ABC is not isosceles, does not contain an angle of 45 degrees.
For example, question, prove that nego P and Q and nego P or nego Q are logically equivalent. First, we need to do the truth table to see that there is identical or not. So after that, we can observe that the true value for column nego P and Q and nego P or nego Q are identical. So we can conclude that they are logically equivalent.
To conclude about this topic, logical equivalence happened when the statement P is true if and only if the statement Q is true. Also, the statement P is false if and only if the statement Q is false. There are 4 types of statement which are conditional, inverse, converse, and contrapositive. From truth table, a conditional statement is logically equivalent to contrapositive due to true value for both statements are identical. Also, inverse statement is logically equivalent to converse because the true value for both statements are identical. Thank you.